Okay, now we're going to talk about what we call unit circle-ish problems. It's going to take us back to SOHCAHTOA. It's going to take us back to quadrants and what we know about the positives and the negatives in different quadrants. Maybe we should just review that real quick. Okay, and I know you know this, but in the first quadrant, all the x's and all the y's are both positive. What about the second quadrant? What do we got? A negative always followed by a positive. Third quadrant is, of course, two negatives, and then the fourth quadrant, positive followed by a negative. So these questions are not going, they might be our special 16 angles, or they might not be. And that's okay either way. Like you might recognize this angle in the first quadrant where sine is 1/2. Isn't that a 30-degree angle? But here's the nice thing, we're not bound to the unit circle anymore. So if you want to go back to saying that the sine of the angle is the opposite over the hypotenuse, you can. And you recognize this anyway, though, as 30, 60, 90. And if I have the triangle set up that way, that side would be root 3, right? So the cosine of that angle would be root 3 over 2. I never had to know what the angle was. I kind of did know it was a 30, but I didn't have to. The next one, it's still in the first quadrant, if the tan of x is 4, find the sine. Okay, so I don't really know what angle has a tan of 4, but I know SOHCAHTOA, right? 4 is really 4 over 1. And then if I want to find that hypotenuse, here's an old friend, a squared plus b squared equals c squared, right? So wouldn't the hypotenuse equal square root of 17? Well, yes, it would. So what's the sine of that angle? Well, sine is opposite over hypotenuse. And of course, we got to get rid of that real quick. So it's going to be 4 root 17 over 17. 4 root 17 over 17. Perfect. So now we march into the second quadrant, and like we said, we notice that in the second quadrant, we know our x-coordinate or our cosines are negative, and this cosine is negative 3/5. Remember, the hypotenuse is always going to be positive. So the negative I'm going to really apply to the x value, and I know my Pythagorean theorem so well that I know that the other side is going to be 4. And now I got to think for a second. Find the cosecant. Cosecant's 1 over sine, or I could say hypotenuse over opposite, 5/4. Sweet. Also in the second quadrant, if the sine is a 1/2, you might be like, hey, I know that angle. That's a 150-degree angle that has a sine of 1/2 in the second quadrant. It sure does. The adjacent side is negative root 3, right? Because it went negative, left, and then up. Tan is, I could do sine over cos, or here I might do TOA. Opposite over adjacent, and then, of course, rationalize it, negative root 3 over 3. Awesome. Okay, so here we are in the third quadrant already. Third quadrant can be a little tricky because you have to remember that it's a negative over a negative. So I gotta think about this for a second. Cotan. Cotan, isn't cotan the opposite of tan? And tangent was opposite over adjacent, so cotan is adjacent over opposite. But they're both gonna be negative. Still create a positive cotan, right? But since it's in the third quadrant, I had to go left and down. Again, Pythagorean theorem will tell me that that's square root of 17. Cosecant, I could do 1 over sine or hypotenuse over opposite. So hypotenuse is root 17, opposite is negative 4. That's why it's nice to have the negative sign like written right on the triangle, and that helps me. Another third quadrant angle, secant. Now it might help you to write that it's over 1. And I got to think about, okay, secant is 1 over cos, or I could write it as hypotenuse over adjacent. Hypotenuse is always positive, so the adjacent would be negative 1. hypotenuse would be 3. And maybe I do want to do like, write it out, a squared, -1 squared plus b squared equals c squared. 1 plus x squared is 9. X squared is 8. Isn't that just going to be 2 root 2 square root of 8? Oh, and it's negative, right? Because I'm in that third quadrant, left and down. So the tangent is, again, TOA, opposite over adjacent. So it would be -2 root 2 over -1, 2 root 2. Perfect. Fourth quadrant. Ooh, almost done. So fourth quadrant, now I'm here. So again, this is actually one of my special angles. Do you know which one it is? It's a 315, good one, yeah. So tangent is TOA, right? Opposite over adjacent. The opposite is gonna be the one that's negative because I'm in the fourth quadrant. I went right and down. So you might recognize that, oh yeah, that's 45, 45, 90, right? It's basically a 315 degree angle. 45-degree family. Secant is 1 over cos. Cos is adjacent over hypotenuse, so 1 over cos would be hypotenuse over adjacent, so root 2 over 1 is root 2. Now some people might be wondering, do I have to show all that work? You do not. You absolutely do not. The more you can figure out in your head and just get to the answer, it's totally fine. But it's helpful to show the work, right? Sometimes we're like, wait, I want to show the work. So let's see. So now here, I don't think this is one of my special angles. Cosecant is 1 over sine, or hypotenuse over opposite. The hypotenuse is always positive. The opposite is going to be negative. I recognize it as a 3, 4, 5. So TOA, adjacent over hypotenuse. So the adjacent is 4 over 5. Cosine's positive in the fourth quadrant. So yes, unit circle-ish. Sometimes there are 16 unit circle angles. Sometimes they're just right triangles in a particular quadrant, but we can still find the trig value. Unit circle-ish.